Okay, so the title of our talk is Sample Count in GE 2020. So it's a joint talk between myself and Yong Sheng. Okay, so earlier this year, right, we had actually almost 2 months, exactly 2 months to the date. It was polling day. And my personal experience was that in the morning, I saw very long queues downstairs because I live quite close to a polling station. But by early afternoon, when I voted, it was a lot better. And at 5 p.m., the elections department actually announced that the polling hours will be extended by 2 hours to 10 p.m. So for most of us, that's fine. It just means that results are delayed by 2 hours. But for poor election officials, this meant that they had to work an extra 2 hours on really a very long day. Okay, so but for most people, the common complaint that I saw on Facebook was, but I want to go to sleep. I want to know the results. And the sample count was now delayed to be maybe about midnight expected, or maybe shortly after midnight. So I guess the question now is, with the sample count, for those people who want to go to sleep early, is it accurate enough that, you feel like you can go to bed? But first of all, what is the sample count? Okay, it's relatively new. It was introduced first in GE 2015. So the idea is that at each polling station, they will randomly sample 100 ballot papers, and when they're at the counting station, and they will add these up for each of the polling stations to give you what is the sample count. Okay, and they only take valid votes. So if they pick up the first 100 votes, there's an invalid vote in there, they'll pick another one just to make up for it. Okay, what is the rationale behind the sample count? So from the ELD website, they do say that the sample count helps prevent speculation and misinformation, and it also allows for officials to check against the final election result. So it's meant to be indicative that when you actually get the results, you don't think that you don't get a huge shock. Okay, but back to our original question, right? Can I go to bed? So the idea is, further sample count is from 50-50. Obviously, the more certain that you are with the outcome, that's the intuitive idea. But obviously the question is by how much, and that's what I want to calculate. And is this the same margin for every SMC and GRC? The short answer to that is no. And we'll see why. Okay, so I actually got this idea, on the day itself at maybe 9 or 10 p.m. So what my idea was that I would do Google Sheets. I would update the sample count in real time, and I'll calculate what is the probability of win. So once all the sample counts are in, you can see which SMC or GRCs are still in play. And then you can decide if it's worth staying up to wait for the actual results. Okay, so I talked about probability of winning. So given the sample count, what is the probability that the actual result is not in favor of PAP or opposition party? You can set it up either way, right? Most of the contests are it's just a straight up fight. Or given the sample proportion, what is the probability that the population proportion is less than 0.5? It's actually the same problem. And this is just a more statistical way of defining the problem. Okay, so we use this idea from statistics called the central limit theorem, which states that if you have n independent random samples, and say you have a sample mean and the variance is, a typo, is sigma square, then for large n, the distribution of the sample mean is approximately normally distributed. It's going to be mean p, and the variance is going to be sigma squared over n. So how do we set this up? Okay, the sample count proportion is going to be what we define as p hat. It's just what you get from the sample count proportion that is reported. And for your binomial, your standard deviation is just going to be p times 1 minus p, and then divide by n. Because we have using the central limit theorem, we have that the variance is going to be p times 1 minus p. So the distribution of your actual proportion is normally distributed just with a mean of p hat, and your variance is going to be p hat times 1 minus p hat divided by n. And one thing about the central limit theorem is that you need a fairly large n for the approximation to work well. And in the worst case, this is actually going to be Potong Pasir, which only has 6 polling districts, i.e. 6 polling stations. So this is actually large enough for the approximation to work. And you note that the variance is actually dependent on the number of samples. So this is why we said that is the margin going to be the same? It's not, because it's dependent on how many votes are actually sampled from each of the districts. Okay, so you're going to see this slide again later. The caveat is, of course, ELD said that they do some weighting of the votes based on the size of each polling district. So we don't actually have the raw kind of like samples from each that is reported. But if you assume that the number of votes at each station is comparable, then the approximation should hold. And we're actually here doing a sampling without the replacement. But in the central limit theorem, we're actually doing a sampling with replacement. But again, if the sample count size is a lot less than the number of voters, then this is not really an issue. The approximation still holds. And in practice, the sample count size is only about 3 to 4% of the actual number of voters in the entire SMC or GRC, or even less. So this is a screenshot of what the spreadsheet looked like. It's not a complete spreadsheet. There's a link in the slides, and you guys can look at it later to see what is the actual spreadsheet like. One thing that is maybe slightly disappointing is that the ELD only gives integral values for sample count, meaning that, like say for alginate, they gave it to be 40, 60. And we know that it's a weighted average, and it's more than 100, right? So you expect to actually see decimal places, but no, ELD just gives you rounded to the nearest whole number. So one possible improvement that I could do to this is to actually account for this and do a plus minus 0.5 calculation to find what's the minimum or the maximum win probability that based on the integral values given by ELD. So based on this, I was actually quite confident that, say, Sengkang would be the second Workers' Party GRC, and I was also very confident that East Coast was still going to be won by the PAP. So conclusion, I could say that there's nothing really worth staying up for after this year's sample count release, because there were only 2 places where there was a small chance of an upset, which was Marymount and West Coast. And as expected, the actual results was actually the same as all the sample count results. So yeah, no, is this the end of the talk? Actually, no, it isn't the end of the talk. Actually, there's more to this, right? And I will let Yong Sheng continue.
Next slide. Next slide. Okay, thanks. Okay, so we'll switch gears a little bit here. So what we're going to do is actually ask a slightly different question. What we're going to ask is was the question whether the sample count did a good job of estimating or predicting what the actual vote share for each party was like. Okay. Now, so let's start by just looking at the numbers over here of what happened on polling day. So in this slide, what I have here is the results for G 2015, just for the SMCs only. First column are just the names of all the SMCs. The second column is the percentage of the votes that went to PAP. This excludes all the. This is only the fraction of all the votes that were valid. So I'm just going to exclude those that were spot. Third column is the sample count that was recorded on polling day. And on the fourth column is just the difference between these two numbers. So just a difference between the 2 percentage points. It's a very crude measure to just sort of figure out how different the sample count was from the actual percentage of the vote share that PAP got. Okay, and so I have to sort of help you visualize the numbers a little bit to make sense of numbers. I arranged the numbers in decreasing order. So the deviations, the difference is arranged from the most positive to the most negative here. So what I observe is that the numbers here, the difference is about in the order of like 2 percentage points. So in objectively speaking, these numbers are small. Okay, so what I think ELD said was that you expect numbers up to 4 percentage points. So this is sort of the correct ballpark figure that we saw. Also, like the numbers, if you look at it, the positive and the negative, they're about equally spread on both sides. So this is what we expect. Okay, unbiased errors. This is sort of like the numbers, the figures that you expect. Next slide. Okay, so this happened this year, just for the SMCs only. Okay, so we do the same thing again. Repeat the same graph. Same tables. First thing that pops up is that the top row here, Kebun Baru, overestimated by 5 percentage points. It's a bit bigger than what we expect. The other thing that we noticed was that there's a lot more positive values. So in some sense, the sample count appears to be like overestimating the actual vote share for PAP more than one might expect. So the question is is there something here? So what we're going to do in the next few slides is going to ask the question how unusual were these numbers? How unusual were these numbers given the actual vote share? Next slide. Okay, so here's the results for the GRCs here. So GRCs different from the SMCs in that the GRCs are much bigger. There are multiple constituencies. So in these cases, you draw a much bigger sample count. And so they are much better estimates of the underlying, the actual vote share, vote fraction here. So this reflects the numbers here. The percentage points are much smaller margin, they're much better estimates. Also, we always saw is that in both the 2015 and 2020, the deviations were sort of equally balanced on positive and negative. So perhaps not too much to say here. Next slide. Okay, let's zoom on this one basic question. Let's answer a simple question, a simplest case. Okay, let's look at what happened in Aokang. What happened in that day was that the Workers' Party had 61.19% of the vote of the valid share and PAP 38.81%. The sample count that evening was 58 to Workers' Party and 42 for PAP. So the question I'm going to ask is how likely, or you can say how unlikely were these numbers that we observed. Okay, next slide. Okay, so let me try to formalize what this question of how unlikely is in the following sense. So what we do is let's assume we take all the voting states from Aokang, okay, from all the polling districts, we mix them in a single box, put them in a single urn, and then mix them evenly. The next thing we do is to draw 900 voting slips. Okay, 100 because there were 9 voting stations. In each station you picked up, you draw up 100 voting slips. So that's what actually happened on that evening. So the question we're asking is given this scenario, how likely is it that we draw 42 or more percent slips for the PAP? Next slide. So we can do this in the following sense. Let X be a Bernoulli random variable. So Bernoulli random variable is it's a random variable that is either 1 or 0. It's in this case going to be set to 1 with probability p equals to 0.3881. That's the probability of that's a fraction of the PAP vote share. Let's draw 900 random variables from this distribution independently. And so the question is, what's the probability that the sum of these random variables is going to exceed 9 times 42? So let's see. in other words, a fraction of more than 42% for PAP. So this number, this quantity, turns out to, you can compute it in terms of the regularized beta function. It's a specialized function that's used quite a lot in statistics. In this case, you compute it, you put it in the machine, you compute it, you get like a number of approximately 0.023. So to put it this way, what it means is that like if you actually put out, to just rehash what I just said, if you actually put all the voting slips together in one box and you put it up randomly, then there's a chance of about 2.3% that you get 42 or higher in the sample count for PAP. So that's the number. Okay, next slide. So there are some caveats. Those are caveats that Shen Ting mentioned, so I will not spend more time on this. Next slide. Okay, so what we did here so far was to compute this 2.3% for one SMC for Hougang. This we have to stress is that like this is done in isolation. So this is done on its own. It's sort of like not so it doesn't regard the rest of it. Now, if you keep doing this, you keep repeating this process, what you see is that like if you do this often enough, you will eventually encounter one that's extreme enough. One that will say like, oh, this is going to happen with like a very small percentage. This will happen by chance. It doesn't mean that there was something strange. It just means that this was always going to happen because you didn't do this often enough. Some of these rare events will eventually happen. So how do we treat these sort of like multiple scenarios? How do we deal with this? This is Shen Ting will take over and tell us how we're going to do this.
Okay, so this is what we call the multiple testing problem. And we said that for multiple hypothesis tests, we denote them H1 to Hm. And we reject the null hypothesis if the test is significant, i.e. if the p-value is usually, when you say 0.05. Okay, the proportion of the false discoveries that you're going to get is going to just be the test is declared significant when it actually shouldn't be, over just all of the number of tests that are declared significant. And the expected value of this is just called the false discovery rate. Okay, so given that there are in total 35 GRCs and SMCs combined together, if we do hypothesis testing for all of them, you just expect to see one significant result just purely by chance. So how do you control for this? Okay, so what we do, this is an idea that was first introduced by Benjamini and Hochberg in 1995. What you do is you sort the p-values in increasing order, and then for each of the p-values, when you sort them, you compare them to the index divided by the total number of tests you do times alpha, where alpha is the desired rate. In usually case, we use 5%, so alpha equals to 0.05. And you find the largest value of k where the p-value, the sorted p-value in the kth position, is less than or equals to the proportion times alpha. Okay, and this is known as the step-up procedure. And what you do is you reject the null hypothesis for all hypothesis tests from 1 to k. Okay. So this is kind of an idea of how what you do when you have many p-values. You sort them from smallest to largest, and then you draw a line that is to alpha, and then when you have the sorted index, you basically just see which is the largest k value where the p-value is still underneath this line. Okay. The diagram is actually from my own master's thesis back in 2012. So what did we get from this? So we already applied this to the p-values that Yong Sheng calculated in Python using just by calling the regularize the binomial function. And there were no significant results actually using the two-sided test. So we're going to test for both sides whether there's any unexpected results. There's none. But if we just use the one-sided test, which is the idea that the sample count, the alternative hypothesis that the sample count is actually overestimating the actual vote share, then only Kebun Baru is significant. So this is quite different when you actually go and look at the full results, which is if you don't do the multiple testing, you will actually find that there are quite a number of constituencies which are significant if you just apply the 5% significance level. But when you control this by applying for multiple testing, only Kebun Baru is significant. And that's if you just use a one-sided test. So guess what's the conclusion, right? Is there imperfect mixing? We don't know. I mean, the fact is that when you're trying to physically mix things like ballot slips, even to the best of efforts, it's very hard to maybe get a perfect mixing. Okay, but I think in general, what we've shown is that even with the so-called skew that we kind of see or bias that in this year's sample count versus actual count, the sample count is actually reliable. And most of the time, it's actually indicative of the actual result unless it's really close, right? So if you follow what the ELD said, for SMCs, it's usually about plus minus 4%. And for GRCs, it is about 1 to 2. Okay. So that's it. I guess there's a bonus insight from this year's results. And this is actually thanks to another friend of ours, Kenneth, who first spotted this. I mean, multiple people spotted it later, but he actually spotted that if you look at this year's results, just by tabulating by the constituencies in which Workers' Party contested in, they actually got a higher overall vote share versus the PAP. Okay, and we've reached the end of the talk. First of all, I personally need to, of course, thank my co-speaker Yong Sheng, because when he saw this, he thought about it and he also did some analysis and we talked about it together. That's why we end up with a more complete analysis. I also like to thank Beyond Su for actually counting the polling, helping me to count the polling districts from the ELD documents on the actual night itself. A few other people, I mentioned Kenneth, two other of our mutual friends, Jing Yi, who was discussing with us about the multiple testing. Sean also gave some helpful comments. And I have to thank Ku, because actually Ku was the one who came and said, hey, I think this is worth a talk. And I guess the point is that, this is not actually a very complex analysis. Most of it I did in Google Sheets, just with Yong Sheng's side analysis for the function he needed to use Python, but that was it. We fed it back into Google Sheets and we did a multiple testing correction within Google Sheets itself just by sorting. Yeah.
Okay. Thanks, Shen Ting. Yeah, you got references that you want to share the references or?
Yeah, so I did a write-up, I reposted it on Facebook. That's where I think Ku came and find me. And the actual sheet is on Google Sheets. I can probably just open it for a bit, given I have a few more minutes to show. One of the idea I actually got is actually Nyam Shitong. He wrote an article from GE 2015 and he wrote about the same thing. How accurate is the GE sample vote count? And for those who are still maybe a bit confused, you can read his article. I think it's quite a good read as well. So I don't think this is not an original idea, and it's just that I happened to decide to do it this year because of the late results.
Okay. I think what we can do is we can share the link on our the Facebook group page, right?
Sure. Thanks.
Yeah, we can share it over there. And then for those of you who are interested to know the formulas behind and all this, you all can have a look at it.